Oh, welcome back to the thing where I cuss a lot and fail at typing. Yeah, it's time for another programming tutorial. I haven't been making them lately because I've been busy with some other stuff, and the next thing that I want to tackle is making a new game. But in order to make that game, I need to create a sprite. And in order to create that animated sprite, I'm going to need some kind of model to base it on. So I posted in the forum. I asked some people some ideas of what they might have for what I can use to basically trace over when I'm making the animation for the sprite. And this is the one I'm thinking of right now. So I'm thinking of maybe using Conrad from the Flashback game. It's got pretty fluid animation, so it should work out pretty nice. But I still haven't finished the program that I'm making that will help me out when I'm rotoscoping Conrad. So I gotta get on that, I guess, someday. But I figure that we could probably do some stuff in preparation for the game that doesn't require me having this sprite. So that's what we're gonna do this time. What we're gonna do is I'm gonna need you guys to, if you remember what we did in lesson, I think the intermediate lesson 2, when we worked on alpha blending, we're gonna continue on from that point. So you should find that project. And if you don't have it, if you deleted it or whatever, never finished it, it's on. I'm gonna upload the zipped solution to the forum so you can get them at the usual place there. But that's our starting point. And we are going to improve the performance of the put pixel routine, especially for alpha blending, because I mean, this is pretty piss poor. I don't know if you remember, but like we're getting maybe what 2 or 3 frames a second there. It's horrible. And it's even getting slower, I think. So obviously this is not acceptable performance for a game. And you can see if you comment out the alpha line, where we draw the dice using alpha blending. Comment that out. You can see it runs fine. We're about 6 milliseconds to draw the entire scene, and that includes a full background. So 100 sprites and a full background, and we still got plenty of time left. So it's not the normal put pixel. It's when we mix in the alpha blending, and the reason why is quite simple. I'll explain it to you right now. Our put pixels are all they're all moving data onto the graphics memory. And the fact of the matter is that writing to graphics memory is a lot faster than reading. There's only a limited amount of bandwidth and resources for the interconnection between the CPU and the graphics card over the PCI Express bus. In order to optimize that connection, the way it works is reading speed is sacrificed in order to improve the writing speed. So it's a lot faster to write to graphics memory than it is to read. And I mean, when you think about it, most games, they're not reading that much from the graphics memory. They're usually just transferring their textures and their vertices over to the graphics memory, and then it's drawing the shit. You don't have to generally read that much from the graphics memory. But because we're doing this software engine to begin with alpha blending, we have to read the value of the back buffer in order to blend it with the value that we're going to blit over it. So that it means that we're reading a lot of data from the graphics memory, and that's why we're going so goddamn slow. The solution is to not read from the graphics memory. And how we achieve that is quite simple. We create a buffer in system memory, a buffer that exists outside of the graphics memory, and we do all our drawing to that buffer. And when the frame is completely done, we just send that buffer to the graphics memory. So that means we never read from the graphics memory. We do all of our composition in system memory. And that means it's faster. It's much, much faster for alpha blending, but it's actually also faster for just normal blending. It's a little bit faster, or a fair bit faster for just normal drawing. So there's really no reason why we shouldn't be composing in system memory and then sending the frame once it's completed to graphics memory. So how do we achieve that? Well, let me think here. Actually, before we do that, I want to do something here. I want to create a new class, so you guys can follow along with me here. Because this is, what do you call it? This benchmarking code here, I don't like it. We're going to create a class that encapsulates all of our benchmarking functionality. So, how are we going to do this? We're going to add a new item to our project. It's going to be a header file. We want to make sure we put the header file in the right place, which is, wait, let me go up. How do I go up? Here. Put it in assets. And we'll call this one, what are we going to call our class? We'll call it frame timer. Because that's kind of what it is, right? And I'll add that. And we'll do our pragma once here. Now, I'm going to make a class frame timer. I'm not going to split it up into an H file and a CPP file. I'm just going to put all the code in the header file. But I do want to put it in a separate file, not put it like in game.h or whatever. Because I've seen a lot of your guys work on the forums, and I've seen some of you guys kind of copy me, like when I did the, what was it? When I did the scoreboard, and I made the class inside the game, just, I don't know, just because I felt like it. So I've seen a lot of you guys making games and using more and more classes, but like putting all the classes inside the game class. And it's, you do it sometimes, but generally speaking, you should have your separate classes in separate files. So I don't know. I thought maybe I shouldn't have done that after a while. Maybe I should have put it in a separate file, just not to give anyone the wrong impression that that's how it's normally done. Because that's not how it's normally done. But enough of that. Let's make a frame timer class. So, public. Haven't coded any C++ in a couple of weeks, actually. Let me think here. Well, we're going to create the frame timer. Actually, I want to figure out what kind of data I have here. Private. Yes. Okay. Well, it would help if I look at... No. Damn it. Where is my thing here? So, we have times some minimum, maximum frame count. What are all these kinds of data? What are you? I had to declare them in here, didn't I? Oh, I got so many variables. Okay. Last min. All right. So you have the right. You have the variables for the current calculation and the variables from the previous calculation. Because right. Okay. I could probably do something with like arrays here and like structures, but fuck it. We'll just make it simple. Doesn't really warrant any kind of complicated solution. I'm just gonna copy all this stuff here. I'm gonna cut it because it's getting out of here. And I will put that in a frame timer. Paste. Perfect. Okay. And it doesn't know about timer, so we'll go include timer.h. Beautiful. Now, so we got the constructor there. What else do we need? We need some functions to get. Well, I guess we need a function to start a new frame. And another one to stop a frame. Right? So, start frame, stop frame, and I guess I need to put a void in front of that. That's what you're trying to tell me with your squiggly lines there. Yeah, okay, what other kind of functions do we need? We need some get functions to get the results. So to get the sum, the min, and the max. So we'll float get some, and that's a const. Float get min const, and float get max const. Right. Yeah, I think that's all we need, really. Now in the frame timer constructor here, we need to initialize our variables. So the timer doesn't need anything, it's just constructed. These guys, they need to be all reset, don't they? Let me just make sure. Time min has to be set to float max, right? That makes sense. Alright, so I could just copy this. That would be the clever way to do it. And we'll just put that right here. Beautiful. Okay, you don't know what float max is. So include float.h. How does that make you happy? You're welcome. If you don't remember, we set it to float max because minimum is only updated if the measured time is less than the current value of time minimum. So if you set it to 0, it'll always be 0 because you can't get a time that's less than 0. So you have to set this one to maximum, to the maximum possible floating point value. And you set the maximum to 0 because that's the smallest non-negative one. And then as you take measurements, they kind of get closer to meeting in the middle. I don't know how to explain this shit. It makes sense. You just look at it. I'm not good at explaining shit. What do you take me for? Okay, so you initialize this, and I think that's all you really need to do, don't you? You don't actually have to do anything. You just initialize. I could be wrong, but that's what I'm thinking. And I gotta get rid of this shit because it's not relevant. It's not kosher. What's the Muslim version of kosher? Halal or something? I don't know why I thought about that, but I did. Okay, so now we need to, yeah. So this is probably going to be the thing that I put in the start frame and end frame. Both of them. It's going to be split up or something. frame time is equal to timer dot time get timer dot start watch stopwatch. So start time will start the watch, and stop frame will stop the watch and then do the calculations. That makes sense. All right. So where's my thing? Start frame. So all this should do is this. Am I right? I think I'm right. Oh, I gotta get rid of that. And what else? Okay, now we got stop frame, which is where all the magic will happen. So, damn it, I keep clicking on, every time I think about game, I always click on D3D graphics. I don't even know why. Must be my ADD. There we go. Delete that. Now here, we put all this happy crappy. We stop the watch at stop frame. And yeah. What else? So we stop watch, and then we frame time is equal to blah blah. Is there anything I need to change? Kind of looks all good to go just as it is. Start, stop. Create this temporary variable, use it to update these ones, and if we are at the maximum frame thingy doodle, then we do some stuff. Yeah. Alright. I'm going to make it a little more parameterized. I'm just going to add one more variable in here. We'll do it static constant float, no, int how much I call it? I don't even know what the term for this is, but I'm just going to call it average n frames average. So the number of frames that we should take our average over. And we're going to set that to 60. Now this might throw you off. This static when put in front of a member variable means that this memory is shared over all instances of the class. So if I have multiple frame timers, there would only be one n frames average in memory, and they would all access it. That's what static does. So if I didn't have static and I just had constant int and I had like 10 frame timers, every frame timer would have its own n frames, but they would all be the same thing. It'd just be a waste. It's not a big deal, but I often make my constants static like that. It's just a thing you can do. Now I put this one here, so I go, oh fuck. What did I do? Oh, why did I copy that? That was retarded. And now I gotta make this one a float. I'll make you a float too. Wait, you're already a float. Okay, so that is our start and our stop. And our constructor is done too. Now we just need our gets. And those are trivial, because all the calculation is actually done in stop frame. So for our gets, we just do return last average. That's not what it is. Return last average. Yeah. Copy that. Paste that there. Return last min. And return last max. Okay. So there we have our class. That only took like 15 minutes, didn't it? Time well spent, in my estimation. Now we can just use that to do the exact same thing that we were doing before, just to test it out. We just want to test out our class here. So I'm going to get rid of all this code here. Oh, wait, I'll leave it. Undo. What I do want to do is I want to add a thing to my hoo-ha to my whatnot. I don't know what I'm saying anymore. My mouth is moving, but no one's behind the wheels. Timer. You couldn't put that final quote in there for me. Lazy ass. IntelliSense making me do all the work. Frame timer. There. Good. No squiggly lines. And then we do, what do we do? Timer dot start frame dot store stop frame, and this is useless, so we just get rid of all this crap. And here we do timer dot get why did I put sum? It's average. Why would I want to get the sum? The sum is not very useful. Why did I type that? Why didn't you guys say anything? You just sitting there laughing at me. Okay. Get average. But I don't need that. And here we want to get min. So timer dot get min. And here we want to do timer dot get max. And I think that is all we need. Let's see how badly this crashes and burns. Fail. I knew that was going to happen. Missing what? Where? What? What are you missing? I can't even see. Where is it? Before graphics. Where's the... Is there like an error? Arrow. Here it is. Fuck. Okay. Okay, that's understandable. Bingo. And let's run it. And yeah, we're getting the same numbers, so that works. We have liftoff, or whatever. I just encapsulated the frame timer in a nice little class there. Beautiful. Beautiful, beautiful. What else do I want to do now? Oh yeah, now we want to do the thing that we were going to do originally, which is first of all, I just want to take a measurement here. This is going to take a while. Actually, I'm going to set this to 20 frames because I want to sit around forever while this fucker averages slow ass frames. So I'm going to get rid of this, and we're gonna measure this. Write this number down because it's important. Ugh, so slow. Lame. So we're getting about average frame time of 306 milliseconds. Wait, now it's 504. Yeah, I don't understand that. It gets slower as you go on. That doesn't even make sense. Isn't it getting slower? It starts off actually faster than and then it gets slower, and I don't really get that. I don't see what would cause that. But yeah, it's kind of it's chilling out now at 553. So it's about 2 frames a second, right? Yeah, our fastest frame is 540, 556, so it's pretty consistent frame from frame. So we'll just call it 550 milliseconds. So I'll just put that right here, 550 milliseconds. And now you can go fuck yourself. Yeah, you. Okay. Now we'll take it without the nastiness. And again, 6.1, 6.2. We'll call it 6.2 milliseconds. We'll just say 6 milliseconds. Fuck, it's just 6. No, we'll say 6.2. 6.2 milliseconds. That's this stuff here without this thing here. Okay, now we have our measurements before. This is like cosmetic surgery. We need the before and afters. So now we're gonna do the thing. Remember what I said it was gonna be? We was gonna make a surface in system memory, and then we was gonna. What was we gonna do? First we're gonna make the system memory. So that's a D3D color. I think that's what you call it. And we're gonna call this. We're gonna make a pointer to D3D color, and we're gonna call it the sys buffer. Sure, sys buffer. That's good. Now we need to actually allocate that memory. We're not going to create the system buffer on the stack because that would just be a huge chunk of shit chilling out in the middle of our stack and probably cause us to overflow and die. So we're going to make a we're going to what's the word I'm looking for? Dynamically allocate that mother trucker. And we do that in the constructor, right? Because well, we want to allocate stuff in our constructor. That's what it's there for. First we look for the constructor and we see it's right here. So after we get our back buffer, the last thing we'll do here is I'll use new for this one. Sure, why not? Sys buffer is equal to new D3D color. And now we need to wait. That's not what I wanted to do. This one, because it's like an array. It's a block of memory. And we want width times height. Now I can't remember in this version if I created a width and a height thing, but I don't think I did. I have to fix that too, but I'll do it later. Before I had to define for the width and the height for some of the versions of the framework, and then I just used that define everywhere, and then if I wanted to change the width and the height I could just change 2 numbers and it would change everywhere in the program, but I didn't do that this time, so we just have to hard code this mother. 640 by 480, whatever that number is, that's how many pixels we got in our system buffer. Okay, so that's our constructor. Then in the destructor we go what do we do? Well, first thing we're going to do is I probably should have done this before, actually. I should initialize all of our pointers to null, which is just 0, by the way. P-direct3D is null, and pointer to what's the next one? That doesn't matter. Where is it? Device. It's always a good idea to initialize your pointers to null. It lets you know whether or not the they're actually pointing to something valid, or whether they've never been assigned. When you're debugging and stuff like that, it comes in handy. It's what you should do. Okay, so back buffer and sys buffer null. I should have called it psys buffer. If I was going to be, what's the word? Consistent. That thing that I'm never. That's the thing. psys buffer. And then I have to change it in here, don't I? No. Fuck. This one. I can never click on the right thing. There. Okay. Now we have our... Yeah, good. Now we have our system, all our pointers nullified. And here we'll go if psys buffer delete psys buffer and psys buffer equals null. It's always a good idea to nullify them again if you've deleted the block that they point to signify that they don't point to anything anymore. It's always just good practice to nullify your pointers, which I sometimes don't do because I'm a horrible person. I'll admit it. Now, here's the magic. In order to modify our D3D graphics, like right now I can add that sys buffer, but it doesn't change anything. I'm still drawing directly to the graphics memory. See, same numbers, same old, same old. In order to make it so that it draws to my sys buffer, all I gotta do is change this to psys buffer. Notice that I don't have to put this cast in front of sys buffer because it already is a pointer to D3D color. So I don't have to do that monkey shit. I just gotta put me some sys buffer, which makes the code look a little prettier, I guess. All right. Wait, what's the difference between this one and this one? Oh yeah, this one uses C and this one uses. Okay, I get it. Gotcha. Okay, so now we have our put pixel, and it's putting pixel into the thing, and what do we do? What do we do? Build. What do you think's gonna happen? White screen of death. Wait, why did that happen? I know why it happened. Okay, we need to change one more thing. And that's this. Maybe it's the pitch. Right, we don't want pitch. We want the width, which is 640. Right. Because we're not using the system back buffer anymore. So we don't use this, we use 640. There's still some stuff wrong, but I think this might fix that crashing problem, maybe. I don't see why it's crashing. I expected the white screen, or at least I expected it not to be what we want it to be, but I didn't expect it to crash. So let's see what happens now. Still crashing. Well, fuck you in the ass then. Damn it. Okay, so this is good. X plus 640, X plus 640, X plus 640 times Y. Okay, that's good. That's fine. Now, what I want to do is I want to 640 by 480. Yeah, okay, that's fine because it's D3D color, so that's fine. Alright, well, let's debug this. Let's see exactly where it's crashing. Right. Okay, so psys buffer. Okay, so our pointer is valid. Okay, so we were writing outside of the memory before we were writing, and the program was letting us do it because I don't know, maybe like when you write to graphics memory like that, it's not as picky. But when you create like a memory block on the stack, it'll tell you right away if you mess something up. That's all I can think of. So where are we doing this from? Draw sprite. Y 481. X offset, Y offset. Why is the sprite being drawn at 481? That seems bad, because the sprite has a height and a width, so it's going to go way below that then, won't it? This. Alright, let's go to compose frame here. Draw sprite instance. Where's draw sprite instance? Why does it go directly to draw? Oh, we're here. We are drawing the background sprite. Okay, if the background sprite is 800 by 600. What the fuck? Oh yeah, fuck. Okay, I'm an idiot. I forgot that our game is running at 800 by 600, not 640 by 480. Hardy har har. Fucker. I don't even know why I thought that. I just thought SVGA, man. Okay, so that would be a problem, wouldn't it? If our surface wasn't the right size. Where's my fucker? Son of a bitch, where are you? You are in graphics. Am I correct? But not this one. You're in this one. Okay. So, see, this is why I need to define with height and width, because I fuck things up like that. No, I don't have that defined. I need it, but I don't have it, so I have to just hard code it. 800 by 600. Yeah, I got you already. I'm feeling you, bro. Wait. This one should be 800. Yeah, that was just another bug waiting to happen, wasn't it? Luckily, if you know how to use your debugger, it's pretty simple to find bugs. If you don't know how to use your debugger, then you're probably fucked. Build solution. Okay, now it should not work, but it shouldn't crash. Okay, it's not working, but it's not crashing. This is what I was predicting in the beginning. Why is it not working? Can you think of the reason? I'm going to tell you, but if you want to think of it yourself, you can just pause the video and think about it. Okay, the reason is because we're putting pixels to our system memory, but we're not actually copying the system memory to the graphics memory. So it's not actually being displayed on the screen. We're just creating all our pretty frames in system memory, and then that's it. They die. And then they die. So, blah. Let's do it, shall we? Let's make code so that we have to do the thing. Talking is hard. Let's copy the system buffer onto the graphics thing. We do that when we're going to end the frame. So, first thing we need is we can get rid of this clear thing here. Why can we get rid of it? Well, this clears the back buffer in graphics memory. But if we're going to be copying the system thing onto the graphics memory, it's going to write over the whole back buffer, and therefore there's no point in clearing it. It's just wasted effort. So we can get rid of clear on the back buffer. We do, however, need to clear the system buffer, but we'll do that later. Now we don't have to lock the rectangle on begin frame because we're not actually writing to the graphics memory until we end the frame. We're writing to the system memory. So I'm going to copy this. Actually, I'm gonna cut this. I'm gonna put it here. All right. So what we do is we lock the rectangle, then we copy over the system memory into the graphics memory, and then we unlock it. Now here's the trick. We could do a loop, like we do for int x equals 0 to 640 and y equals 0 to 480, or we could do a loop like index is equal to 0 from 0 to as long as index is less than 800 by 600. We could do a single loop. It would be the same thing, right? And then just copy all the stuff over. But when you're doing a huge copy of a big block of memory, there's better functions that can more efficiently copy that shit for you. And with a good optimizing compiler, the difference might not be so huge, but to be safe, that I'm going to get good performance, I'm going to use memcopy. There might be better, even faster functions, but memcopy seems fast enough for me. And what memcopy does is it copies the source to the destination, and it just copies in bytes. So the destination is going to be back rect. Okay, we can't do this. We can't just copy it all in one chunk. We have to copy it line by line. What I was going to do is I was going to do something like this. Copy to the backrect from the backrect.p bits. Copy to there from p sys memory, right? You're gonna fucking piss me off, aren't you? Void pointer. That doesn't work. What's the problem? Pieces of memory. Sys buffer. Is that what you want? That's what you want. So I don't need the void there, do I? Good. Okay. So I wanted to copy from the system buffer, and I just do size of, so get the number of bytes in a D3D color times 800 times 600. So just copy the entire buffer over from here to here. But we can't do that because it might work on some video cards, but depending on your video card, sometimes you're going to have a backrect.pitch, right? And I've explained pitch before. It's a number of padding bytes that come at the end of every line. So if there is a pitch, or no, not if there's actually pitch isn't the number of padding bytes. It's actually the size of every line in bytes. But if the size of every line includes padding bytes, then if you just copy all the bytes over, you're gonna get misaligned information in memory, because it's just gonna be fucked up. Like if you remember when we did the bitmap and we didn't include the padding stuff and it was all like diagonal and shit, that's what's gonna happen for people who have graphics cards that are a little bitchy. So in order to avoid that situation, and it's not, we don't actually lose that much performance by doing it this way, so it's not a big deal. We can do this for int y is equal to 0, as long as y is less than 600, y plus plus, and then we memcopy here. But we can't just memcopy from the start to the start, because that wouldn't make any sense whatsoever. What we do is we get, it's going to look really ugly actually, but it has to be done. First we have to cast this to a pointer to D3D color. So we do D3D color pointer to, we say treat this as a pointer to D3D color. Then we have to index it to the point that we're going to be copying, which is y times, 800. Or 800 times y. To be consistent. And then once we index that, we say we don't want the value, we want the address at that point. And that's where we're going to start our copying. That's where we're copying to. And we do the same shit, well, almost the same shit. PSys buffer is already a D3D color, so we can skip that bullshit. But we need to get the address of it at this index. Ah, fuck. Okay, not quite like this, because, yeah, that's not going to work. What we want, actually, this isn't too bad. We don't have to cast this, because we have pitch, and pitch tells us how wide a line is in bytes, including the padding. So all we got to do is we do bits, fuck you, at pitch times y. So back rect dot pitch fucker times y, and then we get the address of that, and that actually looks prettier than the other one. Why are you pissed off? Do you want me to do this? Because I can do this. I can do this just fine. Okay, no, wait, you still don't like it? What is your fucking problem? Expression must be a pointer to a complete object type. Fucking dude. Okay, fine. Void doesn't have a size, right? P-bits is actually a pointer to void, so it doesn't have a size. It doesn't even have a byte size, so we have to treat it like a byte. So we'll do car. We'll say it's a car. Cars are byte-sized. So we have a car. Fuck, that's a pointer to car. Are you happy yet? Finally. I could have just called it like byte. Byte. Actually, I'm going to call it byte. Byte is defined in, I think, Windows or something. See, it defines a car as a byte. I can't point to it because it'll disappear, but you see. Type define, unsigned car, byte. So a byte just is another way of saying unsigned car. So these are pointers to bytes, and we index them using the pitch, and this is a pointer to D3D color types. We index them using the width of the buffer thing. Yes. Now we don't want to do this much. We just want to copy over this much, which is the size of D3D color times the number of pixels in a line. And this should copy over the entire buffer. Then we unlock, we present. So what do we do in begin frame? Well, nothing right now. We'll do something later. So, yeah, that is that. Let's build. See how many errors I get. None. Amazing. Amazing. Now let's see if we actually get something on the screen. We do. It's slower, but we're in debug mode. Don't forget that we're in debug mode. Debuggy mode. So let's put her into release mode and see what the difference is. I think before we had 6.2. Now we're at 3.3. So that's almost twice as fast. Not quite, but pretty damn close to twice as fast. And remember, this is without any alpha. So let's enable the alpha on that mother trucker and see what kind of a boost we get to performance. Ooh, it's time for the big reveal. I got goosebumps. So we had 550 milliseconds before. Let's see what we have after. 4 milliseconds. It's actually faster than our other one without alpha, without drawing the alpha sprite. You see how simple it can be to get a nice fucking performance boost. I love this shit, man. I just love it. So, we got our performance boost. We got our alpha blending at a decent speed. We can probably draw a lot of shit alpha. But if you notice, it's hard to explain how to put this. I guess the easiest way to explain it would just be to show you. I'm going to comment this shit out. Comment. Actually, I'm not going to do that yet. Sorry. What I am going to do is, let me think here. I'm going to comment out the background because I want to show you something that we've missed. I got to present these ideas in an order here. So first we comment out the background. What do we get? We get crazy shit. So can you conceive of why this crazy shit is happening? How good is your conceiving skills? Well, the reason why the crazy shit is happening is because... Fuck you. Blarg. Buh. I just had to burp there for a second. That's not the one I wanted. Here. It's because we're not clearing our system buffer before we draw our new frame. So all the old frames, they still remain. And we're just drawing over top of that shit. And that all just kind of accumulates. And we get this kind of after image effect here. It just gets all fucked up. Okay? So obviously that's not usually what you want. It might be an interesting special effect sometimes, but usually you want to clear the buffer before you draw a new frame to it. Now you didn't notice it before because we were drawing a background image that wiped out the entire buffer, right? But if you're not wiping out the entire buffer, if you're not sure to clear it all out, you have to clear it yourself. Most games that you do, you will be clearing it out just by drawing your background or whatever. But and in that case, you shouldn't clear it out manually because you'll just be wasting extra memory accesses. But we're going to clear it out here because I want to show you another function. So you got memcopy for copying memory from one location to another. You also have memset, which can set memory to a certain value. Now I think memset is also bytes, even though the value is an int. It actually sets them in bytes, so go figure, whatever. So the destination is psys buffer. The value is going to be black or white. Say white. Fuck. Yeah, I'll just say OXFF. So because we're copying bytes, it's kind of messed up. We have to... It's going to copy FF, the byte FF, over and over and over again. So we'll get FF for our red, green, blue, alpha, red, green, blue. Well, it's actually X. X, red, green, blue, X, red, green, blue. So we're not copying one pixel at a time. We're copying one channel at a time. But it's all done in the function. Doesn't matter. Now, the amount that we're going to do is size of... Again... D3D color, that's the number of bytes in a color times the number of pixels in a line times the number of lines in a frame. So notice that we don't have to do a loop in this one because this is our system buffer and it does not have any padding. It's nicely arranged in memory for us to access it. So we don't have to monkey around with fucking looping through every single line and mem setting. We can just set the whole damn thing in one memory call. And if we do this shit, then shit will be good. Hopefully. Yep, see, now we're all cleared out. Beautiful. And you see that's much faster than when we did it with the... Oh, well, never mind. Never mind what I just said there because I was going to say something stupid. Okay, so... That's how we do our begin frame. That's how we clear our frame out if we are not sure to clear it out with the background image. Yeah, throat's starting to hurt. Talking too much. Not used to talking this much using my YouTube voice. Okay. And I clicked on the wrong thing again, didn't I? Yeah. So, now I can do the thing that I was going to do before. Except I forgot what that thing was. Oh, goddamn Alzheimer's. Alright, I think I was going to actually, I knew I was going to comment this out, but I don't remember why I was going to do it. And that, my friends, is a problem. Right, okay, now I remember. Good. So let's say I draw this alpha 1.5 milliseconds to draw just the dice. 1.5 milliseconds. So you see this dice graphic is actually pretty large. All this white space, it's being processed as well. So it's actually like this big, and that's a lot of sprites. So we could, I mean, if you multiply this by 10, you get about a frame. So we could do quite a few sprites in alpha blending. But I want to show you something. Just draw a sprite. We're going to draw it without alpha. It's going to look fucked up, but that's okay. So that was 1.5 milliseconds drawing in alpha. Without alpha, 0.54. So as you can see, it's about 3 times slower to draw with alpha than it is to draw without alpha. So if possible, we want to avoid drawing shit with alpha. Only things that need to be alpha blended should be alpha blended. That's just a performance issue. Just because we can draw pretty fast with alpha doesn't mean we should draw everything with alpha. We should still pick and choose. I mean, if your game is using very few sprites, it doesn't really matter. But if you're starting to push the limits of the current engine, then you should consider dividing shit up between stuff that needs alpha blending and stuff that does not need alpha blending, and drawing them separately using different function calls. So that's what I was going to talk about there. Now, if you're drawing your background there, like this. Oh fuck, I gotta draw that with alpha. Alpha. Build and go. Yeah, fuck it. Okay. So yeah. 4.8. Seems actually faster than it was before. I can't remember. Anyways, 4.8 is a fuck of a lot faster than 550. So we're definitely on an improvement here. But there is one little caveat. And that is, before we were drawing directly to the graphics memory, and then when we were finished drawing, all we needed to do was flip, which is basically instantaneous. But here's the deal. Now, when we're finished composing our frame, there is still one more operation that takes a fair amount of time. And that operation is... what is it? Fucker. Where is it? Here it is. Here. The mem copy. Because that's moving a lot of memory from the system buffer to the graphics thingy. So, it should really be taken into account. So let's figure out how long it takes to do a mem copy. And to do that, we need our trusty thingamabobber. Now where is it? We need our frame timer. Right. Now here's the problem. The frame timer is part of the game object. And it needs to be part of the game object because it's called in compose frame. Here it's called in order to get the information. But we also want to be able to use it in D3D graphics because I want to be able to time this thing here. I want to be able to time this. So I'm going to do something that's not a good thing to do, but I'm going to do it anyways. I'm going to make a global variable. Dun dun dun. Let's make a global variable here, people. D3D graphics.cpp. So I'm going to include frame timer. Actually, before I do that, I want to do one thing here. I want to get the time 4.8. 4.8. So we go to game.cpp and I'll just put another one in here. 4.8 milliseconds. So that's the time to draw all this shit with the new engine. But we have to add to that time also the time it takes to transfer a completed frame to the graphics memory. Otherwise we don't get the full picture. So let's create a frame timer here. This is global, so it can be seen by all these functions. And it doesn't belong to the graphics class. It's its own thing, just floating out in our program. Now we're gonna do... Fuck, where can I find shit? Where's my shit? Timer.start frame. Timer. Wait, end frame? Fuck, can't remember what it's called. Stop frame. Yeah, that makes sense. Start, stop. So we'll time here. Now in game, we're not going to have a timer in this one here. I'm going to get rid of this timer. Actually, I'm just going to comment it out because I might need it later. And in game.cpp, we're not going to time this, and we're not going to time this. So now this is going to complain that, hey, what the fuck? Where the fuck is timer? So what I do is I go here, and again, this is bad stuff that we don't normally do, but it's a lot easier than the alternative. I'm going to do extern frame timer, and that will allow me to access the frame timer global that is actually declared in D3D graphics. So this timer can be accessed from game now as a global variable. I think I explained this when I was explaining static before. So now we can have a timer that is timing shit in graphics, but it displays its value here. Again, there are other ways of better doing that with like pointers and shit, but fuck it, it's too much work. And this is just a temporary timer thing. This isn't actually part of any game or anything like that. So let's see how long it takes to transfer a frame to graphics memory. So you can see it only takes about 0.757, on average about 0.78, whatever. Less than a millisecond to transfer. So we get a little bit of overhead from this, but it's not too much. It's not huge. So all in all, we're looking at, well, let's see, 0.7, so that's 5.5 milliseconds. 5.5 milliseconds to draw that mother and send it to the video memory, as opposed to 550 when we were doing it all in video memory. So that's a speed up of a factor of about 100, pretty much. I mean, there's some stuff here that didn't use the alpha, and so it doesn't have the same scaling. But all in all, for the alpha part, we're at about 100 times faster. And we're close to twice as fast just with normal drawing. And that's nothing to sneeze at. We can double the amount of sprites we have on screen without alpha. And with alpha, we can have 100 times more sprites on screen. That's just good. It's just all good shit. Alright, so that is the end of this lesson. Or lesson / upgrade / whatever. Whatever you want to call it, that's what it was. And we got a little bit of extra practice in making a class and using it, so that's always good. Making lots of classes in the next game. It's going to be all fucking classes. Because classes are good. They're classy. Now, I don't know when I'm going to be able to get the sprite shit done for the next game. Because I've got to finish my sprite rotoscoping program. And then I've got to get the source material and actually rotoscope the sprites. I might actually ask for some people for some help on that if I can get it. But it all depends on stuff that happens in the future. However, I do have an idea for another lesson in the interim between when we actually start on the game. I want to improve the keyboard. Because God knows it can be improved. I mean, in the vanilla, there's some people who have posted code for more keys and stuff on the keyboard. But in the vanilla framework, we've only got like how many keys here. And also, if you're making a game where, for example, you want to move a cursor and you don't want it to move like 60 spaces a second, you've got to do extra stuff to make sure that only key presses are registered. Single individual press events are registered, and it just makes things harder. But it turns out that we can do it a lot better if we modify the keyboard class. We can get all the keys on the keyboard, and we can make shit like typing in your name or whatever a lot easier than it is right now. So, next lesson will probably be an upgrade to the keyboard system, and it'll probably be shorter, a lot shorter than this one. Maybe 30 minutes, if I'm being optimistic. And I mean, after that lesson, I should definitely have the at least the first animations ready for the sprite, so that we can start making the whatchamacallit, the game, the platformer. The sprite is going to be it's going to be a Stickman sprite, based on the animations from Flashback, I think, unless I get a better idea before then. So if you guys got good ideas for what I can copy from for the animation for the sprite, by all means let me know, because well, Flashback is good, but I think we can do better probably for a number of reasons. So yeah. And I mean, the thing that I want to, I'm going for is, like, if you ever seen like the stick fight or whatever, they got these videos on YouTube, not this one, but like something like this. Aw, you fucker. Hurry up. Okay, good. There. So like, yeah, just take a look at this shit. That's not too bad, ain't it? I mean, you can make a pretty sweet-ass game using just like stickmen and shit. And that's basically my my goal. So the enemies and the player will just probably just be different colors or whatever. But it's going to be stickmen. I mean, the weapons will probably be something different, and I'll have to figure out how we'll work them in, and that'll be later on. But anyways, yeah. Stickman. It's going to have a Stickman game. It's going to be sweet. Sort of. But only if I can get off my ass and make the program, the rotoscoping program, and then actually make the sprites. So, in the interim, we will be upgrading the keyboard. And now I am going to play Faster Than Light, probably. That game has wasted so much of my time already. So good. So good.